Okay, so we're going to talk about functions, but we're going to talk about the pieces of a function first. And these words were used in the video. I don't know if you noticed them or not, but input and output are synonyms of these words. So the first word is domain. So domain is always going to be our X value. It's also called the input. So whatever number we are putting into that function would be considered either our domain, our input, or our X value. All of those three words are interchangeable. So the opposite would be our Y value. Our Y value can also be called the range. It can also be called the output. So we put in a domain, we get out a range. We put in an input, we get out an output. We put in an X, we get out a Y. All of those are different ways to say the same thing. So we are specifically going to talk about functions. So functions are a specific type of relationship. And that relationship happens when every input only gives me one specific output. So if we look at this is called a mapping diagram. Has anyone ever seen something like this before? Maybe, maybe not. Okay. This is just a way to show points X, comma, Y. So if we look at this mapping diagram, I want you to put an X over the left-hand oval and a Y over the right-hand oval. So we're going to actually write the points out. So the first point, the X value is 6. And I want you to notice that a line is drawn from 6 to what other number? Firstly, -3. That's the first point. X's value is 6. The Y value is -3. The input is 6. The output is -3. What other value does 6 have a line drawn to? 5. Okay, so that's our second option. 6 goes with 5 also. The input is 6. The output is 5. What other points could we write from this mapping diagram? Input is 8, output is -3. And the last one would be input is 15, output is 5. So we need to determine, is this relationship a function? Well, I hope you see that 6 input is going with 2 separate outputs. 6 is going with -3 and 6 is outputting 5. Because that's happening, this is not a function. For it to be a function, that 6 is only allowed to be paired with one output value. And in this case, it's paired with 2 output values. It's paired with -3 and it's paired with 5. So this is not a function because 6 has more than one output. So we can actually represent relationships in many different ways. So we're going to look at all the ways we can represent relationships. The first way is a mapping diagram. So on the left is a mapping diagram that's not a function. On the right is a mapping diagram that is a function. And you'll notice the reason why this one is not a function is 6 has 2 outputs and 6 5/12 also has 2 outputs. That's not allowed for it to be a function. But for the right-hand side, 12 only has 1 output, 15 has 1 output, and 8 has 1 output. So because that's the case, that would be considered a function. What about the table on the left? What makes that table on the left not a function? Yeah, Henry.
Because 2.3 has, what is it called? Oh.
You're good. Use your words.
Oh, it has 2 outputs.
Yeah, so 2.3 input has 2 outputs. 2.3's output is 7.4 and 6.8, and that's not allowed to happen. And then what makes the one on the right a function is you can see each of those individual inputs are different. So they are all going to various different outputs. So that's what makes it a function. Okay, this one is written as points, as coordinates. So on the left, tell me what makes that one on the left not a function. Trey?
Oh, the input -4 has 1 and 5.
Yeah, right. -4's outputs are 1 and 5. And that's not allowed for it to be a function. What about the one on the right? What makes that a function as opposed to not? Robert?
All of the inputs have different outputs.
Right. All the inputs have different outputs. And you can see that all the inputs are different. So I really don't care what their outputs are. As long as our inputs are different, then that's all I care about there. Okay, now, oops, I forgot to delete that. What about these two graphs? I'm going to tell you that the graph on the left is not a function. Madison.
So I think it's because, yeah, 2 has 2 functions.
Two. Can you say outputs?
2 outputs.
Yeah, let's say outputs. So if I look at x is 2, so that's right here. 2 as an x value has multiple y values. 2, 1, 2, 2, 2, 3, 2, 0, 2, -1, 2, -2, 2, -3, 2, -4, 2, -5. That value x input of 2 is giving me out multiple outputs. So that would not be considered a function. What about the one on the right? It's giving me one specific y value. Every time it is not corresponding with another y value. It's going to a different y value each time. And there's actually a test that we can do for that. And we're going to skip this question. We're going to jump down here. So it's actually called the vertical line test. Vertical line test. Vertical, which way is vertical? Yeah, up and down, right? Vertical line test. So when we have a graph, we can determine if it's a function by the vertical line test. It may be helpful if you have a highlighter. If that's not the case, not the end of the world. But if you have one, it might be helpful for you to take it out. Thought I erased all this, but allegedly I didn't. So if we look at these two graphs, I'm going to take my highlighter and I'm just going to draw vertical lines over whatever shape is drawn on the graph. So I'm going to do that here. And I'm going to do that here. And again, you can use your pencil. You don't necessarily need a highlighter. I think it just makes it a little bit easier to see it with a highlighter. Just my personal opinion. Okay. So do you notice anything that's different of the one that's not a function on the left versus a function on the right as far as the, oh, I'm sorry, Selena, the last line doesn't matter, Selena, because that's a horizontal line. We want it to be a vertical. We're worried about the vertical lines. Okay, good question. What do you notice about the one that's not a function versus the one that is a function? Yeah.
The one that is a function has 4 lines. And the one that's not a function.
Okay, well. I don't care about that, but that's a good observation, but that doesn't matter as far as determining if it's a function or not. Yeah.
So for the first one, at the top, it goes like backwards, and then it goes forwards and forwards.
Okay, that does matter, yes. When we draw these vertical lines, for it to be a function, it cannot touch more than one part of that curve at the same time for the same vertical line. And you'll notice that right here, although I'm not perfect, but this is supposed to be vertical. This vertical line touches 2 parts of that graph. It touches it here and here at the same time. That is not allowed. Just like if we looked back at the one before, if I drew a vertical line right here, it's touching all of those points of that graph. So that would be considered not a function. You are only allowed to be touching one piece of this graph at the same time as for it to be considered a function. And I don't want you to get confused. It only counts for vertical. I don't care about horizontal. Horizontal means nothing to me. I care about vertical lines only. And you'll notice in the one that is a function, I'm only touching that curve at one point at a time as I draw my vertical lines. Now, I know on your computer you can't necessarily draw vertical lines, but what you can do is you can take your pen and you can kind of move your pen across the screen and just make sure that your pen is never touching more than one piece of that graph at the same time. And here, I'll show y'all. You can just take your pen vertically and you can just move it across your screen and make sure that's not touching more than one piece of that at the same time. So that's a different way to tell if it's a graph. So we can tell by mapping, we can tell by a table, points, what else did we do? In graphs, I think that was it. Yeah, in graphs. So we're going to look at this type of graph. Does anybody know what type of graph that is? Yep. I'm more worried about the shape than the slope or anything like that. It's a line, yeah. Mind blowing, right? It's a line. We usually call it linear, right? Linear graph because it makes a straight line. And when we get back from winter break, this is all we're going to do for like a whole month is like linear graphs, a lot of them. And the equation that goes with this, not as important right now, and I've kind of mentioned this before, is y equals mx plus b. And you'll notice that that's written right there in that same form. But now that we're talking about functions, we are not going to write y, like the letter y. We're going to write it in what's called function notation. Someone asked me second period where function notation comes from. That's one of those questions that I don't have the answer to. I can try and look it up during lunch, but I didn't have time second period. But what function notation is written as is we are going to pick a letter. Usually it's an F for function, right? And then we're going to write whatever input variable is in parentheses. In this case, our input is X. So that is function notation. And we read that by saying f of X. That's what it's saying, a function of X. So our output is depending on whatever my X value is. So if we look at this graph, my Y value or my output is depending on whatever I pick as my X value. So if I picked my X value to be 4, that's going to determine my output or my Y value. So this is written as f of X. If there's multiple functions, usually we start with f and then we say g of X and then h of X and then m of X. Like there's multiple different ways to write functions, okay? Like multiple different letters. But usually if it's just one, we use f. Neil said the new way of writing functions is called function notation. It was introduced to mathematics by Leonard Euler in 1735, so a long time ago, way before you or I were even thought of or alive, okay? So we are going to be using this new function notation to describe functions. So instead of 2 different variables like y and x, we're going to use f of X or f of whatever that input variable is. And might not always be X. A lot of the times it's time or height or some other variable. So let's look at an example. So this says at sea level, the air presses down on our bodies at 14.7 pounds per square inch, or what's called PSI. When diving in the ocean, the pressure increases. Has anyone ever been like scuba diving or snorkeling or anything like that? Okay, when you scuba dive or snorkel, you can't just like go scuba diving. You can't just like go rent equipment and go scuba diving. You have to like get approved or trained to do it because the pressure, you have to learn to breathe on a little machine, obviously, but you have to get used to the pressure. Like when you're underwater, far underwater, the pressure of the water gets really heavy on you and you have to like that's why like people that scuba dive can't be down there for more than like a certain amount of time because the pressure can get so heavy that like serious injuries could happen. So as you go further underwater, the pressure gets more and more. So this equation, it represents the pressure that happens the farther you go down under the water. So how do we know that this is a function? Well, there is no double output here. So every time I input X is the number of feet, I'm going to get a specific output. I can't input a 2 and get out 2 different numbers. So each input corresponds. How do you spell that? Corresponds? I think we're going to go with that. To only one output. Is that how you spell corresponds, guys? Come on, help me out. Okay, thank you.
Oh, wait.
Maybe not. Corresponds, looks good. No, there's 2 R's. I did look that up. So this equation has a y. We want to replace that. We want to write that with function notation. So it's telling me to use P. So we're going to use P. Our input variable is X. So we're going to write P of X equals, and we're not going to change anything else about that equation. We're going to leave it as 0.445X plus 14.7. Ouch. And part C is asking, what is the value of the pressure when you are 2 feet under the water? So when X equals 2, how much pressure are you having on your body? So let's go ahead and find the value of this function at 2. That means wherever I see an X, I'm going to replace it with a 2. And I will give you a second to calculate what that would be, hence why I asked you to get a calculator today. So you want to multiply 0.445 times 2 and then add 14.7 to that. What'd you get, Asa? 15.59. And for this problem, that would be in PSI, so pressure per square inch, I think is what that related to. And then sometimes the math is already done for you. This says P of 50 equals 36.95, but we need to decide, what does that mean for this? That means when you are 50 feet under the water, the pressure is 36.95 PSI. So we didn't necessarily need to calculate anything. We just need to see that P of 50 equals 36.95 means that if I'm 50 feet under the water, my input is 50, I'm gonna have 36.95 pressure. My output would be 36.95. Okay, so let's talk about something that is not a function. The table below gives the number of letters of the winning word for the Scripps National Spelling Bee. Side note, I love the Spelling Bee. I watch it on it's on ESPN every year. I don't know if anybody's ever watched it before, but I'm really into watching it. It's very interesting to me. There's also a documentary on Netflix about one of the spelling bees, about the people in it. So yeah, if you're like looking for something to watch, it's really good. And the number of people killed by venomous spiders for the years 1999 to 2009. So first thing, does the length of the word in the spelling bee have anything to do with the number of people that die via venomous spider? No. Okay, let's make this connection, Kale. Bees are insects. Spiders are not. Spiders are arachnids, not insects.
The more letters they put in the spelling bee, the longer the
Okay. Okay, cool. Moral of the story is they have nothing to do with each other. So this is not a function. One input of the spelling bee word is not going to output 10 people passing away via venomous spider. Okay, so we are going to prove that it is not a function by showing that. We're going to show it using this mapping diagram. So we're going to make a mapping diagram. So we're going to say that the left oval is going to be spelling bee. And the right oval is going to be spider. When you make a mapping diagram, you're going to list the numbers from least to greatest, and you're not going to repeat. So if we look at spelling bee, the list of spelling bee length, what's the smallest word? How many letters? 7. What's the next smallest? 8. The next smallest would be 9, then 11, 12, and 13. Again, I don't care that repeat. We'll show how it repeats in a second. And then if we're looking at spider, 4, 5, 6, 8, 10, and 14. So in a mapping diagram, how we show the relationship is we draw lines. So for 7, under spelling bee, what number does that pair with under spider? 5. So we're going to draw a line from 7 to 5. So that shows which year 7-letter word matched or 5 people dying by venomous spider. And then there's only 1 7. Yeah. So what about 8? 8 goes with 5. And there's only one of those. 9 goes with 6. 9 also goes with 4. 9 also goes with 8. So we're going to draw multiple lines from 9. And then the last one, 9, goes with 6 again. We're not going to draw that one again. We'll just leave it as one line. 11 goes with 5 and 8. 12 goes with 10, and it goes with 10 again. So we'll just draw one line there. And then 13 goes with 14. Yeah, 2004 was a bad year. Long word and a lot of people dying via spider. Is there a relationship? No. And there is no relationship, well, mainly because they have nothing to do with each other. But if we look at the mapping diagram, it's not a function because 9 and 11 are both going to multiple outputs. Multiple outputs. Yes.
So wait, so what if 9 went to like the same number 3 times, not going to different ones?
Then that would just be the same output. Because that means no matter what, if there's a 9-letter word, that same amount of people are going to die, no matter like what year it is. So that's a good question. Even if, so that's the same, like, I think it was 12. 12 went to 10 twice. That's still 12 only going to one output, right? Even though it's listed twice in the table, it's still getting the same number out. Okay.
If you look at the table, usually the more spelling bee letters equals more people dying. So
yes, but usually is not all the time.
Actually, the least number of letters. Oh wait, that doesn't make sense.
Okay, exactly. It doesn't make sense. Hence, not a function. Okay, so let's look at the 2 beat the test questions, and then I'll ponder. Just ignore me for a second. So the table shown represents the data of honey-producing bee colonies in the U.S. and the marriage rate in Vermont for the years 1998 to 2002. So does the number of bee colonies determine the marriage rate in Vermont? No, probably not. Okay, probably not. But the question is asking which of these, A, B, C, or D, is representing a function. Okay, I don't care that they don't have anything to do with each other. I care which one is representing a function. Okay, so if we look at A, remember when we're determining a function, we are looking at the inputs or the X values. So looking at letter A, is it a function?
No.
Okay, so which pair tells me it's not?
No. Oh, wait.
Are you sure?
The first one is second pair.
The first, okay, I'm glad you said that. Do I care that both the first and the second are paired with 10?
No.
I don't.
So
I
that's
also
it,
don't
huh?
care that the third and the fourth are both paired with 9.8. I care that each of those X's is only going with one Y. Each of the X's is all individual. I don't care that they share the same Y. I would care that two Y's share the same X. That's what I care about. Yes. So yes, I would consider this a function. So we're probably done, but let's just make sure that B, C, and D are not functions. So if we look at B,
No, because
it's
there's
not.
dots, like, right above it.
Right. If I drew my vertical lines, I would be touching two of those points at the same time. So B would not be considered a function. For C, 10 is going to 260, right? And 9.8 is also the same thing. And then if we look at D, remember our inputs are in the parentheses, 9.7, 9.8, 9.8, 10, and 10. It's not. 9.8 is going to 2,550 and 9.8 is going to 2,574. So I would consider that not a function. So the only one that was a function was letter A. The other four representations were not functions. Okay, let's look at number 2. The cost to manufacture X pairs of shoes can be represented by the function C of X equals 63X. C of 6 equals 378. So it's giving me an answer. So what is that 6 representing? Yeah, Madison.
Number of pairs of shoes.
Right, we have 6 pairs of shoes. How much is 6 pairs of shoes gonna cost? $378. Again, we don't have to do anything. It's already giving me the answer there. I just have to determine what that answer means. It means that if I buy 6 pairs of shoes, I'm going to spend $378 or manufacture, 6 pairs of shoes. It's going to cost $378. Okay, so before we talked about what a function actually is, so now we're going to kind of evaluate some things with functions, look at graphs of functions, add and subtract functions, that sort of thing. So here's an example of a function. So a ball is thrown in the air with an initial velocity of 15 meters per second. This function, negative 4.9 t squared plus 15t plus 3, represents the height of the ball at any given time. And we're going to determine first h of 2. So what that means is how high is the ball off the ground after 2 seconds? And what we're going to do is we're going to take that 2 and we are going to substitute it in for all the t's in that equation. So negative 4.9 times 2 squared, can you close your computer please, plus 15 times 2 plus 3. Kale, can you close your computer for me please? Thank you, sir. So again, I'm letting you use the calculator. Make sure you're following order of operations. Go ahead and calculate what that would be. How high off the ground would the ball be after 2 seconds? Be careful, especially with that exponent, please. Chopstick in here. Okay, the first thing you should do is apply that exponent to the 2. So that would give us negative 4.9 times 4 plus 15 times 2 would be 30 plus 3. Negative 4.9 times 4 is negative 20.6. Did I do that right? You could be right. I'm doing it in my head. What's negative 4.9 times 4? Negative 19.6 plus 30 plus 3. So that would be 10.4 plus 3 would be 13.4.
Yes.
And specifically 13.4, is it meters? Meters. I want you to look at the graph. If we're at x equals 2, which is right here, are we about at 13.4 meters on the y?
Yes.
So that means my answer probably makes sense. So we could have looked at the graph to get like a general idea of what the answer should be, but you need to use the equation to get an exact specific decimal, because I cannot look at that graph and know that that point right there is at 13.4. You may say 13.2, 13.3. So make sure you're using the equation when you're actually calculating it. So what about if I asked you to find h of negative 3? Does that make sense? Find a height when the time is negative 3. Why not?
Because you can't throw a ball at the ground.
Yeah, no, it doesn't deal with the height. Yeah, we can't. Who's a time traveler? Raise your hand. I wouldn't tell someone if I was a time traveler. I'm just letting you know. So nobody's a time traveler that I know of, and you can't go negative time. So h of negative 3 is not reasonable because you can't have negative time. You could technically have negative height. Where can you go to be negative in height? Yeah, the ocean. Yeah, technically we measure height at sea level, like ground level. So if you're going underneath ground level into the ocean, your height would technically be negative. So here is the graph of that ball. So makes the shape of what happens when you throw a ball. You throw it, and then what happens at the very end? It hits the ground, right? It hits the ground. About how many seconds is it taking to hit the ground? Yeah, about we'll say 3 or 3.25-ish, around there. Right here is where it's hitting the ground. How high off the ground is the ball starting? 3, and I think we're in meters. Yeah, 3 meters, right? 3 meters. What's the tallest height of the ball as it's thrown?
13.4 meters.
Nope, that's when it's at 2 seconds. Look at the graph. About right here, which is about 4 meters, 14.2-ish meters is about the highest height that the ball's getting, which is about 40 feet. Okay, so we're going to talk about these 2 words a lot, domain and range. And just a reminder from before lunch, domain is X and range is Y. Nihal, I'll get, when we're done, remind me and I'll help you with that one, okay? When we're talking about a reasonable domain, we want to describe all the possible X values for this graph. So the X values go all the way from 0, and our X values end right here when that ball hits the ground. And that is between 0 and, let's call it 3.3. And we're going to write this as a compound inequality. So we are using T, I think it was, for time. Yep. So my T, my time, is between 0 and 3.3. That would be considered our domain for the ball and how long it's in the air. It was in the air from 0 seconds all the way until it hit the ground at 3.3 seconds. So when we're talking about y, we're talking about our height. So what is the lowest height of the ball? 0, right? Eventually it hits the ground. What's the highest height of the ball? No, what's the highest height of that ball, guys? About what? 14 point?
14 and a half.
Sure. I didn't hear you. Sorry. So I do want you to think about that because your height, your lowest height might not necessarily be where you start. You got to look at the graph. Where is the lowest point on our graph as far as height goes? It was at 0. The highest point on our graph was up here at about 14.5 meters. Okay. All right. I want you to turn the page all the way until you get to this right here. We're going to skip a lot. Luckily, this is review, hopefully, in theory. We've added and subtracted things before. Combining like terms is what that translates to. We're just now going to look at it in function notation. So here are 2 expressions. And all we are doing is we are going to add those 2 expressions together. Meaning we're going to combine like terms. So we're going to add 2x squared plus x minus 5 plus, and I'm going to put them in parentheses, negative 3x squared plus 4x plus 1. And remember, when we combine like terms, we can only add and subtract things that have the same variable, same exponent. So let's look at the first one, which would be our x squared. So we have 2x squared plus negative 3x squared. What would that be? Negative 1x squared, good. We can also combine 1x plus 4x. That would give us 5x. And then our constant terms would be negative 5 plus 1, which would be minus or negative 4. And that would be all we could do there. We can't combine anything else. So what's different about the one below it? I'm still h of x and g of x. I'm going to subtract them instead of add them. So I'm still using, yes, Lena, subtract, not add. I'm still using 2x squared plus x minus 5, but now I'm going to subtract negative 3x squared plus 4x plus 1. So again, I still have the same like terms, but make sure that you're now subtracting the 2 terms instead of adding them. So 2x squared minus negative 3x squared. 2x squared minus negative 3x squared. What would that be, Robert?
5x squared.
That would be 5x squared. Because when you minus a negative, you're technically adding. So 2x plus 3x squared would be, or sorry, 2x squared plus 3x squared would be 5x squared. What about x minus 4x? Minus 3x or negative 3x, good. And then our constant term would be negative 5 minus 1. Minus 6, good. Again, should be review. We have done this. We just haven't looked at it in terms of it being a function. All right, let's look at two more. We'll say probably 2 more together, and then I'm gonna have you do 2 or 3 on your own. So let's look at the let's practice number 1. So this is giving us 3 different functions. So we have f of x, g of x, and h of x. So the first one is asking me to take f of x and subtract g of x. So let's do that first. So we have 3x squared plus x plus 2 minus 4x squared plus 2 times 3x minus 4. Before I combine, I need to do one thing. What is it, Henry?
Distribute the 2 with parentheses.
Yeah, let's distribute that 2 inside that inner set of parentheses. So I still have 3x squared plus x plus 2 minus, hey. I would ask why, and then I don't know. I don't know. I would, either one's fine. Okay, bye. So then we have 4x squared. 2 times 3x would be 6x, and 2 times minus 4 would be minus 8. And then we can combine our like terms. So first one is our x squared. So we have 3x squared minus 4x squared. What is that? Negative 1x squared or negative x squared. And then we have x minus 6x. Negative 5x. And then our last one is 2 minus negative 8 plus 10. So we have negative x squared or negative 1x squared minus 5x plus 10. All right, let's do this last one together, and then I'm gonna have y'all do 2 on your own. So this one is asking us to do what? G of x minus h of x. G of x minus h of x. So let's start with g. So 4x squared plus 2 times 3x minus 4 minus 5 times x squared minus 1. So again, just before we do anything else, let's distribute. We're going to distribute the 2 again, and we're going to distribute this 5. So that would give me 4x squared plus 6x minus 8 minus 5 times x squared would be 5x squared. 5 times minus 1 would be minus 5. And then we can combine. So we have 4x squared minus 5x squared. We got a trend here. We got another negative 1x squared. Is there a like term with the 6x?
No.
Nope. So we just have plus 6x. And then our last constant term is negative 8 minus negative 5. Negative 3. So we would have negative 1x squared plus 6x minus 3. Okay, before you do the next one, listen carefully. In A, you're adding F and G together, but on letter B, see that M? Well, I hope you notice that there's no M up here. What's M? Yeah. Yeah, so your answer to letter A will be used to do letter B. So just keep that in mind. Okay, so go ahead and try those 2. Digital students, go ahead and send me the answer to both of those when you finish them. 3x squared plus x plus 2 plus 4 plus 2 times 3x minus 4. And I hope you notice these were the same exact ones from the first 2 problems we did. So combining 3x squared, oops, this should be x squared, and 4x squared would be 7x squared. We have to distribute here to get 6x minus 8. combining x and 6x would be 7x, and 2 minus 8 would be negative or minus 6. Pretty much everybody I looked at had that one. And then letter B, you had to take h, which was 5 times x squared minus 1. And you had to subtract your answer from A, which was 7x squared plus 7x minus 6. Obviously, the first thing you should have done was distribute this 5 to get 5x squared minus 5. Now, I had a lot of people mess this up. The first term was fine. 5x squared minus 7x squared is negative 2x squared. Then a lot of people just wrote plus 7x. It is not plus 7x. Because if you look here, it says what sign? Minus or negative. Minus a positive is minus or negative 7x. You have to take into account that sign at the beginning that goes with everything in those parentheses. And then you had negative 5 minus negative 6. Negative 5 minus negative 6 would be plus or positive 1. So the answer to that one would be negative 2x squared minus 7x plus 1. Yeah.
Are you supposed to do the beat the test test?
We're about to. Yeah. So beat the test. English is hard sometimes, and I'm not saying that like to be funny. It is, okay? When I first read this beat the test, I got it wrong. I answered letter A the first time I did it. That's not the answer. When I read it, it says, which of the following is resulting polynomial when f of x is subtracted from g of x? A lot of us may write it like that. That is not correct. When you're subtracting something from something else, like if I subtract 7 from 14, I'm actually doing 14 minus 7. So if I'm subtracting f of x from g of x, I actually want to take g and subtract f. So you have to determine the right order or you're not going to get the right answer. Yes.
It's not answered.
Mm-hmm.
I think the answer is C.
It is C. So let's talk about why it's C. So the first thing we want to do is take our g of x, 5x squared plus 4x minus 1. And we're going to subtract 2x squared plus 3x minus 5. So we want to take 5x squared minus 2x squared, which would be 3x squared. So just doing that eliminates what two answers?
The
A and B, because both of those have a negative 3x squared. And then I can take my middle term, my x term, 4x minus 3x would be x. Guess what? You don't even have to finish it because which one of those says 3x squared plus x? C.